Every night when you look up at the moon, you're seeing the same face, the same craters, the same dark patches, the same patterns that humans have been staring at for thousands of years. But turn the moon around, and it looks like a completely different world. The far side has almost none of those dark plains. It's brighter, more rugged, covered in craters, and its crust is 20 kilometers thicker than the side facing us. For decades, scientists have been trying to figure out why. And the answer turns out to involve a time when the moon was brand new. The Earth was a ball of molten rock, and the two were close enough to fundamentally shape each other. This is the story of the moon's hidden face. First, a quick bit of mechanics, because this confuses a lot of people. The moon isn't locked in place. It rotates, but it rotates at exactly the same rate that it orbits Earth, roughly once every 27 days for both. The result is that the same hemisphere always faces us. This is called tidal locking, and it's not a coincidence. It's the end result of gravitational interaction between Earth and the moon, which slowed the moon's rotation until it synced up with its orbit. It happened surprisingly fast, too. Scientists estimate the moon became tidally locked within just months of forming, back when it was much closer to Earth, possibly only about 20,000 kilometers away instead of the 384,000 kilometers it is today. So the far side isn't dark. It gets just as much sunlight as the near side. It's just permanently turned away from us. We literally cannot see it from Earth's surface. Until we sent spacecraft around the back, it was completely unknown. When the Soviet probe Luna 3 sent back the first photographs of the far side in 1959, scientists were stunned. They expected it to look roughly like the near side. Some craters, some of those big dark patches we call maria. Instead, it was almost entirely highlands, heavily cratered, bright and rugged, almost no maria at all. The numbers are striking. About 31% of the near side is covered in maria, those dark volcanic plains that form the face most of us recognize when we look up at the moon. On the far side, just 1%. So what's going on? The answer starts with the moon's crust. NASA's Grail mission in 2012 confirmed that the far side's crust is significantly thicker, about 60 kilometers on average, compared to around 40 kilometers on the near side. That 20-kilometer difference turns out to be the key. The maria formed billions of years ago when large asteroids and comets slammed into the moon with enough force to punch through the crust, allowing molten basaltic lava from the mantle to well up and flood the impact basins. On the near side, the crust was thin enough for this to happen regularly. On the far side, the crust was simply too thick. Impacts would carve out enormous craters, but the magma couldn't reach the surface. So you get craters, but no dark lava seas. But that just moves the question back one step. Why is the crust thicker on the far side in the first place? This is where it gets really interesting, and where scientists still don't fully agree. The leading explanation goes back to the moon's formation. About 4.5 billion years ago, a Mars-sized object slammed into the early Earth. The debris from that collision coalesced into the moon. At that point, the moon was much closer to Earth, maybe 15 to 20 times closer than it is now, and it became tidally locked almost immediately. Here's the key detail. The early Earth was still incredibly hot from the impact. Its surface was molten, radiating temperatures above 2,500 degrees Celsius. That extreme heat baked the near side of the moon, keeping it molten longer, while the far side, facing cold space, cooled faster. As the far side cooled, elements like aluminum and calcium condensed there first, and combined with silicates to form a mineral called plagioclase feldspar, which floated to the surface and built up a thicker crust. The near side stayed too hot for this process, so its crust remained thinner. Essentially, the moon has two faces because of where it happened to be pointing when it was born. The Earth literally cooked one side and left the other to freeze. There are competing theories. One suggests a second, smaller moon collided with the far side early on, adding extra crustal material. Another proposes a dwarf planet-sized impact created the asymmetry. The debate is still active, but the tidal locking and Earth heat explanation is currently the most widely accepted. After those first blurry Soviet photographs in 1959, the far side remained largely out of reach. The Apollo astronauts saw portions of it through their windows, but their orbital paths and lighting conditions only allowed brief glimpses. Geologist astronaut Harrison Schmitt on Apollo 17 actually lobbied NASA to land on the far side in a crater called Tsiolkovsky. NASA rejected the idea. The risk was too high, and they would have needed a dedicated communication satellite to maintain contact. The technology wasn't ready. It took until 2019 for anyone to actually land there. China's Chang'e 4 mission set down in the von Karman crater on the far side, a genuine first. To make it work, China launched a relay satellite to a special point in space where it could maintain line of sight with both the lander and Earth. Then, in 2024, Chang'e 6 went a step further. It collected samples from the far side and returned them to Earth. No other nation has done either of these things. This is part of why China's lunar program gets so much attention. They're not just going to the moon, they're going to the parts of the moon that nobody else has reached. All of this exploration has been robotic. Cameras and landers, no human eyes. That changed this April. The Artemis II crew flew within about 4,000 miles of the lunar surface at closest approach. Far enough to see the moon as a full disk, but close enough to observe surface features in detail that photographs alone can't fully capture. NASA's science team assigned the crew about 30 geological targets to observe and photograph during a 6-hour flyby window. Two of the biggest targets were the Orientale Basin and the Hertzsprung Basin. Orientale is remarkable, a nearly 600-mile-wide impact crater that straddles the boundary between the near and far sides. It's about 3.8 billion years old and still preserves dramatic ring structures from the original collision. The crew was able to study it from multiple angles as they passed by. Hertzsprung, nearby on the far side, is older and more degraded. Comparing the two gives scientists insight into how lunar features erode over geological time. The lighting conditions during the flyby were actually scientifically valuable. The far side was only partially illuminated, which meant long shadows stretched across the surface. Those shadows reveal depth, ridges, and crater rims that are nearly invisible under full sunlight, like shining a flashlight at a low angle across a textured surface. Christina Koch described looking out the window and sensing something was off before she could articulate it. The dark patches weren't in the right places. It wasn't the moon she was used to seeing. The crew compared what they saw to their study materials to identify features in real time. And there's a reason NASA wants human eyes on this, not just cameras. Human vision is remarkably sensitive to subtle changes in color, texture, and terrain. Astronauts can notice things and make connections that robotic imaging might miss, especially when they can observe from shifting angles as the spacecraft moves. For about 40 minutes behind the moon, the crew lost all contact with Earth. They were completely alone, farther from home than any human has ever been. One feature on the far side deserves special attention because it's going to matter a lot for the future of lunar exploration. The South Pole-Aitken Basin is one of the largest confirmed impact structures in the entire solar system. It stretches roughly 1,600 miles across and up to 5 miles deep. The asteroid that created it hit with such force that it carved through the crust and may have excavated material from the moon's mantle. Rock from deep inside the moon that we've never been able to study directly. Despite its enormous size and the fact that the crust there is extremely thin, the basin floor is surprisingly lacking in volcanic plains. Only about 3 to 4% is covered in lava. That's one of the strongest pieces of evidence that crustal thickness alone doesn't explain the near side and far side difference. Something else, likely the concentration of heat-producing elements on the near side, drove the volcanic activity. The basin is a prime target for future missions, including potential sample returns that could tell us about the moon's deep interior and the history of impacts in the inner solar system. The far side isn't just scientifically fascinating, it's strategically important for the future of space exploration. Because it permanently faces away from Earth, it's shielded from all of our planet's radio noise. That makes it one of the best places in the solar system for radio astronomy. A telescope on the far side could detect signals that are completely invisible from Earth's surface. The South Polar region, where the far side meets the near side, is where both NASA and China are planning their crewed landings. The permanently shadowed craters there may hold water ice, and understanding the far side's geology is essential for choosing safe and scientifically valuable landing sites. What the Artemis II crew observed this week, the terrain, the lighting, the geological features, will directly inform where Artemis IV touches down in 2028. They're not just sightseeing, they're scouting. For billions of years, the moon kept one face hidden from every living thing on Earth. We got our first grainy glimpse in 1959. We've sent robots to land there. And this April, 4 humans swung around it closer than almost anyone in history. What they saw was a world that looks nothing like the moon we think we know. And that's exactly why we need to go back. I covered the Artemis II mission and how it compares to Apollo. Link is on screen. Subscribe to keep exploring with me.